Another way that we can express our architecture is in a structural fashion. This means that if we have a drawing of our circuit like this, in this case we have 3 gates, 3 AND gates and 2 OR gates. We can use this description to directly, or we can translate this drawing into VHDL in order to execute our logic. The only thing that we need to keep in mind is that any signal or any wires connections that are not between the input and the output must be assigned. They must have names. So that's what we'll do in our declaration. So we start with our keyword architecture. We're going to call this one structural, and I'm going to go and with the same entity that we've been using. In this case, I'm just going to go here and say begin. But before we begin and before we go into our statement part, we need to declare our signals. So I'm going to use very self-documenting names, so it's very easy to follow. Now that we have declared our signals, we can proceed to declare our components individually. So let's start with the first AND gate. So the first thing we do is we assign an individual label for it, and then we can proceed with the component instantiation. Now there are 2 ways of doing this, direct and indirect component instantiation. I'm going to use the direct approach. That means I have to enter the keyword entity and address my entity by name and using the work folder. Okay, and now I have instantiated our first AND gate, and as you can see that I'm sending the input, I'm getting the first 2 bits from our input vector and sending it straight to our gate. So if we take a look at our circuit, I'm taking A and B straight into our gate, and then the output I'm redirecting to this signal that I already declared up here. So I'm going to do the same for gate 2. Just have to make sure I change the tag and I do the address of the porting appropriately. So in this case I'm going to take B and C, and the output will go to and 2. So in this case, this time I'm getting the 1 to 0. So if you, this is index 2, this is index 1, and this is index 0. And we are not addressing them as A, B, and C because this is just for the circuit. We are addressing as M input. So now that we have 1 and 2, let's do number 3. Now number 3 is a little bit different because we cannot address the vector directly. We need to take the first and the last. So we need to take 2 and 0 into our gate. And in this case, we will need to do that individually. So we'll address the first input, the input 1, gate input 1, and that's going to take the first bit of our vector, and then we're going to do the same for the last one, but instead of getting the bit, the first one is going to take the last. Okay, and there we go. And the output of this thing goes to gate 3. And now we have instantiated our 3 AND gates. Now let's do the OR gates. So OR gate 1. Now just like gate 3, we cannot address it directly, so we need to address it, the bits individually. So OR input 1 gets AND output 1, then OR input 0 goes to AND 2 output, and then OR output goes to OR 1 output, our signal. So that was our first OR gate. Now let's copy that and paste it for our gate number 2. So we're going to do the same thing here. We're going to address the bits individually. So in this case, the first input of our OR gate is going to be the output of the first OR gate. And the second input is going to be the output of the third AND gate. And lastly, the output of our last OR gate, or our second OR gate, is the output of our circuit. So that's the majority output. And with this, we conclude the structural approach to our architecture.